Welcome back, everyone. So this is going to be part 2 of the video. In part 1, we went through these 6 graphing problems and graphed them both rectangularly and on a polar curve. So down here, we're going to go through the 10 types of polar graphs that you can expect to see. So starting off, we give you just a circle where the equation is going to be just r equals x, where the x value is going to be the radius, and it's going to be centered at the pole, which is the center of your graph. So if I give you a polar equation of r equals 3, that means we're going to go to the third circle from the pole, the third concentric circle from the pole, and then this would be our graph, just simple little circle. So then if I give you an r value of 7, whoops, I think I did it at 8, I can't count, everything's fine. There we go. So then we have a circle with a radius of 7. And then we can technically give you any sort of radius value. So we can give you a radical value where you might have to approximate it. We can give you a decimal value. Just be prepared for just kind of anything. So because we give you a radius value of 4.5, then this would be about halfway between 4 and 5, and it would look something about like that. Then next, we're going to have what we call horizontal circles. So horizontal circles are going to have the equation r equals x times cosine theta, where that tells you that the x value is going to be the diameter, and then if the x value is positive, it's going to open to the right, whereas if it's negative, it's going to open to the left. So if I look at my equations over here, I'm going to have r equals 1 cosine theta, which tells me I'm going to have a diameter of exactly 1, and then because it's going to be positive, that means it's going to open to the right. So I'm going to have a circle with a diameter of 1 that's going to be right here at close to the pole. Now with your horizontal circles, they're going to open right and then have some sort of diameter, or they can open left with some sort of diameter. So this is kind of the idea of what they're going to look like. So just wanted to show you this kind of little graphic. There. Now for the next one, so now we have r equals -4 cosine theta. So that means we're going to have a diameter of 4, and it's going to be on the left side of the pole. So I'm going to put the right side of the circle on the pole, and then I'm going to extend this to the fourth concentric circle on the left side. And then that would be your circle. So we're going to go ahead and go down to the next section. Now we're going to have what we call vertical circles. So that means our equation is going to be x times sine of theta. So if we have cosine, that tells you it's going to be horizontal. But if we have sine, that tells you it's going to be vertical. So that's going to be your big difference here. And just like before, your x value is going to represent your diameter. And then if it's positive, it's going to open up. Whereas if it's negative, it's going to open down. So once again, just to kind of give you an idea, your circle is going to pass through the pole, and it's going to go either up if it's positive, or it's going to be going down below the pole if it's negative. So this is potentially what your vertical circles will look like. So just any sort of these combinations. So I believe this one was a +2 sine theta, so that means we're going to go up 2. Yep. And then that bottom part of the circle will be crossing through the pole. So now for the next one, now we have r equals -8 sine theta. So we're going to have a diameter of 8. And because it's negative, it's going to go down. So then this would be our circle, kind of. Looks like I missed a bit. Close enough. Ta-da. Moving on. Now down here, we're going to look at what we call a limacon with an inner loop. Now, I know you'll probably look at the wording and think, what the heck is that? Now, this C right here, the way that you write it, it is a C, and then the accent that's below it, it looks like a little c. So it's a tiny little c underneath the C. I don't remember the actual name of the accent, but it is a limacon with an inner loop. Now your equations are going to be in terms of either sine or cosine. So we can do a plus b cosine, or we can do a minus b cosine. And same idea with sine, we could do a plus b sine or a minus b sine. So that generates 4 potential equations that we can have. And these 4 equations over here are what I refer to as the big 4. We're going to use the big 4 pretty often with these equations. So anytime I mention the big 4, I'm just referring to these equations here. So if we are ever dealing with a cosine equation, that means it's going to open horizontally, which means we're going to have y-intercepts. And then if I ever have sine equations, we're going to be opening vertically, and then we're going to have x-intercepts. And those intercepts are going to be based off your a value of your equation, which is going to be the standalone number that is not with your trig function. So when we look at the limacons with inner loops, now we're going to take a look at the notes over here. What's going to be super important that you need to kind of have as your takeaway is going to be the ratios of your a and b values. That's what's really going to distinguish your polar graphs from one another. So if I simplify my a and b value ratio and I see that it's less than 1, that is what's going to tell me that it's going to be a limacon with an inner loop. And then to find the outside length, we're going to take the absolute value of the individual values and then add them together. To find the inside length, which is your inner loop, you're going to take the absolute value of a and b, find the difference, and then take the absolute value of the difference. So remember, we're taking absolute value because your distance can never be negative. And then over here, we're going to always pass through the pole since we're always going to be crossing through the x-axis. So I'm only going to do a couple of these. I'm not going to do all 4 of these. So with number 10, notice how we have a positive cosine. So positive cosine tells me that we're going to open to the right. And then because we're doing a cosine graph, what this tells me is we're going to have y-intercepts. And then the y-intercepts are going to be plus and minus whatever your a value is, which in this case is going to be 2. So that is going to generate your y-intercepts in this case. And then we want to find the length of the inner loop, which is going to be our short side. So the length of the short side is going to be the difference of the absolute values. So I want the absolute value of 2 minus absolute value of 4, which that's going to give you 2 minus 4, which is going to be negative 2, absolute value of that, which is going to give you positive 2. And then for the longer side, we're going to take the absolute value of the a and b value, and then we're going to add them together. So we're going to have 2 plus 4, which is going to give you a length of 6. So what's going to happen is your short and your long side here are going to go in the direction that it opens. So to start off, I'm going to have the pole, then the y-intercepts, which are going to be plus and minus 2. And then I want the short side that's going to go to the right of the pole, and then the longer side, which is going to be to the right of even that value. Now, in order to draw your limacon with the inner loop, once again, I'm going to actually start and refer to something I did in the previous video. I'm going to start with a circle. I'm going to put the right side of that circle on that far right point. I'm going to extend it so that the circle passes through those y-intercept values. Use my partial eraser and get rid of these segments to the left and get rid of that segment. And then what I'm going to do, I'm going to have to draw this next part by hand. It's going to come down, pass through the pole, loop around that point, pass through the pole again, and then connect back. So then we're going to draw down, pass through the pole, pass through the point, pass through the pole again, and then come down. And then this would be your limacon with the inner loop. Now over here, I'm going to go ahead and do, let's do number 13. So I have a negative sine graph, which tells me this is going to open down. And then for the next part, sorry, y'all, hold on. My phone's going off. Whoops. There we go. Okay, so now for the next part, now I'm going to have a sine equation. There is a fly around me that is harassing me. Hello. So the sine equation tells me I'm going to be referencing x-intercepts. And then my x-intercept here is going to be plus and minus 4. And then I need to find the short and the longer side. So the shorter side is the inner loop. So you can just say the short side. And then I need to find the length of the longer side. So the short side is just going to be absolute value of 4 minus the absolute value of 5. And I want the absolute value of that. So that tells me it's going to be 1. And then I want to do both of those values added together, which would give me 9. So once again, I'm going to pass through the pole. I have x-intercepts of 4 and negative 4. And then the short side, which is going to go 1 down, and then the longer side, which is going to go 9 down. So once again, let's start with a circle. Bring it all the way up to pass through those side points. This fly is harassing me, I swear. I'm going to throw hands with this bug. And somehow I would probably lose. Okay, now I'm going to use partial eraser, get rid of that. Then use the whole eraser and get rid of that. Now, once again, over here, I'm going to connect it all, pass through the pole, loop around, pass through the pole again, and then come back and connect it all. Oh, that's terrible. Close enough. We'll take it. So I'm just going to do those two. I will definitely recommend you do the other two either on your own and then check it with the note key or come back to them. But you definitely, I would recommend practice those. Now for the next section, we're going to look at what we call a cardioid. So a cardioid, the way that I like to remember it is the word cardio is in the word cardioid, and a cardio makes me think of a heart. So these shapes are going to be more heart-shaped. Now, a cardioid, it is going to be a type of limacon. So all these graphs that we're doing, not all of them, most of these graphs that we're doing are going to be type of limacons. So just know that limacon is kind of the umbrella term. And then once again, we're going to have the big four referencing all this information again. So that should be a recap of what's above. And then over here, just know that your ratio, when you simplify A and B, that ratio is going to be exactly equal to 1. Where the length on the side that it opens is going to be A plus B. Or rather, it needs to be the absolute value of A plus the absolute value of B. And then once again, it's always going to pass through the pole. So let's do 15. So with 15, because we have a negative cosine, that tells me it's going to open left. And then, because we are dealing with a cosine equation, that's going to tell me that we have y-intercepts, which are going to happen at plus or minus 5, which we're going to get from your A value. And then the length of the longer side is going to come from adding the A and the B value together. So I want 5 plus 5, because we're doing the absolute value, which is going to be 10. So I am going to have y-intercepts at 5 and 5 and negative 5 rather. And then we're going to have a length of 10. So it's going to go all the way around, or all the way down rather. So it feels appropriate to use pink or red for a heart shape. So I'm going to put my circle on that side over there, extend it, use my partial eraser again. I'm going to get close to the points so that we don't have any extra marks. And then it's going to pass through the pole. So then it's going to look, hopefully, more heart-shaped. Ideally, it should be a little bit more rounded than that, but it's okay. Alrighty, and let's go ahead and do 16. So 16, same idea. Now we're going to have a positive sine graph, which tells me this is going to open up. And then we're going to have x-intercepts, which is going to be at plus and minus 6. And then the length of your cardioid is going to be the summation of the A and B values, which is going to give you a length of 12. Now, your graphs only go up to 10, so I chose this one on purpose just in case. So if you absolutely need to, which in this case we do, you can do a scale on your polar graphs, which it won't be very often or very common that you need to do a scale. But in case your values do get too big for your graph, you can do a scale. Okay, so when I plot my points, I'm going to have x-intercepts at, whoops, follow my scale, hello, 6 and 6, since I'm doing a scale of 2. And then I'm going to have a length of 12, and it's going to open up. Whoops. Partial eraser, so y'all know the next steps. And then we're going to pass through the pole. So some people say it looks like a butt, but I don't really care. Call it what you want. Just draw it. Okay, Now we're going to look at the next section. So this one is going to be called a dimpled limacon. So a dimpled limacon is still going to follow the big four, but your ratio here is now going to be between 1 and 2. So we're still going to follow the same techniques and same mechanics as we did with the limacon with the inner loop. So it's still going to be the smaller length and longer length. And notice that, or not notice, but know that this one does not pass through the pole. So this is the one limacon that's not going to pass through the pole. Or the one limacon that we're going to do that's not going to pass through the pole. So with the dimpled limacon, so I'll do number 18. So I have a positive cosine, which tells me it's going to open to the right. And then I'm going to have, my brain stopped working, y-intercepts at positive and negative 4. And then my short side is going to be 4 minus 3, which is 1. And then the longer side is going to be 4 plus 3, which is going to give me 7. So what's going to happen here is the longer side will go towards the direction that it opens. The short side will go to the opposite side, which means this will actually be on the left side of the pole. So when I plot my points, so I'm going to do my y-intercepts. And then for the longer side, I'm going to go to 7, but the shorter side is going to go to just 1. So once again, I'm going to start with the circle. Expand it. Use my partial eraser. And then for the rest of this one, it's going to be a little wavy, which is kind of how I like to describe it. Nope. Close enough. We can do better than that, I guess. Apparently I forgot how to hold a pen. Close enough. Same idea. All right, and then let's jump over and do the next section. Just kidding. Let's just do the next section. Okay, so I'm actually going to save the roses for last because these are the ones that just make me want to start sobbing. So we're going to go ahead and move on to the lemniscate and the spiral of Archimedes, and then we'll come back. So the next one we're going to do is what we call a lemniscate. So a lemniscate is essentially a fancy way of saying a figure eight. So the figure eights are going to go in a specific way. So here's your equations first off. So the lemniscates are the only equations that have an r squared. So that's also a really good kind of telling feature that your equation's a lemniscate when your r is squared. Now for your equations over here, the x value, notice how it's just x and not x squared, just the x value. So you're going to need to take the square root of that coefficient to find the length from the pole. So if we have a cosine function, that means it's going to be a figure eight kind of going horizontally, so left and right. So it's going to look something like this. Now, if we have a sine lemniscate, it's going to be going diagonally. So a key feature that you will need to know about the lemniscates, if I have a positive sine lemniscate, then that means it's going to be going towards pi over 4 and 5 pi over 4. So it would look something like, that's terrible. It looks something like that if it was positive. Now, if it's a negative sine lemniscate, then that is going to go towards 3 pi over 4 and 7 pi over 4. So it would look something more like that. Now, a common question I would get is, how do you know that? Well, the short answer to that is you would just have to graph it rectangularly, which if you want to discover that, I will let you discover that wholeheartedly on your own. But I also don't want this video to be 5 business days long. So if you want to discover that, I will leave you to it. So over here for number 30, we have r squared equals 25 cosine of 2 theta. So what's going to happen here, in order to find the distance from the pole, I know I need to take the square root of 25, which means I'm going to have a distance of 5 on either side of the pole. And then because we're dealing with the cosine equation, that tells me we're going to be going left and right. So I'm going to go to 5 on either side of the pole, and we are going to pass through the pole, and then it's going to be a figure 8. or an infinity sign, whatever you want to call it. Now for 31, so now we're dealing with a sine equation, and it's a positive sign. So that tells me that we're going to be going towards pi over 4 and 5 pi over 4. So we're going to be following kind of these directions. So in order to find the distance, I know my x value is going to be the square root of 49, which means the distance from the pole on either side will be 7. So I'm going to go to the 7th concentric circle, and then we're going to also include the pole. And that would be your graph of your lemniscate for sine. Now looking over here, now notice how these are going to have reflections since we make them negative. So if I look back at my cosine equation, if I were to make this negative, it means this top half would then reflect down. But if you notice, if I reflect a cosine one, it's just going to be the same shape. But if I were to reflect the sine one, that's why this one's now going to go like this, and it's almost going to look like a rose. So over here, I still need to find my x value, which is going to be the square root of that coefficient, which is going to be 10. So I'm going to go 10 to the left and to the right. So my graph kind of got cut off a little bit over here because they're all so close together, but that's okay. So then my graph is going to look close enough. Graph is going to look a little wonky, but it's okay. Now for 33. So same idea, but this one's negative, which means it's going to follow the 3 pi over 4 going in the direction of 7 pi over 4. So my distance here, my x value will be the square root of 36, which means I'm going to have a distance of 6 on either side. So I'm going to do a distance of 6, a distance of 6, and then my graph will look like that. Ta-da! So there's your lemniscates, which are figure eights. So now we're going to come down here, and we're going to do the spiral of Archimedes. So there are no notes on this one. My one note is that I'm terrible at drawing these. That is my note. So with the spiral of Archimedes, what I will say is this is going to be where the angle, this is where the distance from the pole is going to be equal to the angle that it goes in the direction of. So meaning, if I were to make a little makeshift table down here, so I'm going to go 0 in the direction of 0. I would go pi over 2 in the direction of pi over 2. I would go pi in the direction of pi, 3 pi over 2 in the direction of 3 pi over 2, 2 pi in the direction of 2 pi, then what was it, 5 pi over 2? Yes, math is hard, y'all. 5 pi over 2 in the direction of 5 pi over 2, and then we will go 3 pi in the direction of 3 pi. So if I were to kind of do the decimal expansion of all these, well, 0 is obviously 0. Pi over 2 is about 1.57, and then pi, as we all hopefully know, is 3.14. 3 pi over 2 is going to be about 4.71. 2 pi is about 6.28. 5 pi over 2 is about 7.85. And 3 pi is approximately 9.42. So what you're going to do, so for this one, what we're going to be doing is we're going to plot these values. Sorry, y'all got sidetracked. Someone tried to come in my room, but it's okay. She was very nice. So I'm going to do 0, 0, or try to. And then I want to do 1.57, 1.57. So pi over 2 in the direction of pi over 2, which is going to be about over here. And then pi in the direction of pi, which is going to be 3.14, which is going to be about over here. And then in the direction 3 pi over 2, we're going to do 4.71, which is almost 5. And then in the direction of 2 pi, we're going to do 6.28. And then in the direction 5 pi over 2, which is the same as pi over 2, we're going to go 7.85. Which is about over there. And then in the direction of 3 pi, which is the same as pi, it's going to be 9.4. And I believe it's going to be somewhere in this area where we're going to equal 10. So I don't remember the exact value. I think it's around 4 pi over 3-ish. So your spiral would look something similar to this. That's honestly probably better than most of my drawings. So it's going to look, oh wow. So usually I have to do this segment by segment because I was drawing it so terribly. Okay. Wow, it's all still so terrible. Close enough. So it's going to look something like that. So this is about what it would look like. I mean, this should definitely be a little bit more curved in specific places, but it's the idea. So I'm not going to worry about the other two graphs. As long as you can recognize the equation and the spiral, honestly, I'm happy. So now let's go up and do the roses. So with the roses, I'm only going to do a couple of these. So we have an odd rose when it has an odd number of petals, and then we have an even rose when it has an even number of petals. So our equations are going to be using either sine or cosine. So if it's cosine, it's going to be symmetric about the x-axis. And if it's sine, it'll be symmetric about the y-axis. So same thing. And then over here for your rules, so your x value is going to be the petal length, which is your coefficient. So essentially the same idea as saying like the radius or the distance from the pole. And then your n value, if it's odd, that is going to be the number of petals we have. So over here, let's look at number 22. So what I like to do with these is kind of come up with a period and then develop a table. So for these, what I'm going to do is I'm going to start with a period. So the period is going to be 2 pi over the b value, which would be 2 pi over 3. And then I'm going to do the period spacing, so 2 pi divided by 3. And then I'm going to divide that by 4, which means I'm going to do 2 pi divided by 3 times the fourth, which is going to be pi over 6. So what this tells me is when I create a table, I'm going to count by pi over 6 on my table. So I'm going to make an r comma theta table. Let's bring it over here. Or shoot, sorry, that should not be a r theta. It should be an xy table actually, because I'm going to do it rectangularly first, and then I'll convert it to polar. So I'm going to count by pi over 6, so I'm going to have 0, 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, then 5 pi over 6, and then pi, which, yeah, I'll just stick to these values for now. So what I'm going to do is I'm going to plug in these values to my equation up here so that I can get some coordinates. So if I plug in and do 0, that would be 5 cosine of 3 times 0. So that would be 5 times cosine of 0, which would be 5 times 1, which is just going to be 5. And then over here, I would do, 5 cosine 3 times pi over 6, which then that's going to do cosine of pi over 2. Cosine pi over 2 is 0. 0 times 5 is 0. And then 5 cosine 3 times pi over 3. So cosine of pi, which is -1, -1 times 5 is -5. So I'm just going to keep following this pattern. 3 times pi over 2. So that's going to give me 0. And then 5 cosine 3 times 2 pi over 3, which is cosine of 2 pi, which is 1, times 5, which is 5. and then 5 cosine 3 times 5 pi over 6, which is going to be 5 pi over 2, which is going to be 0. And then 5 cosine of 3 pi, which is going to be the same as pi, which is going to be -5. So now, if I want to plot these in a rectangular coordinate, you could make a new table, you don't have to, but now this would become my r value, and then all the angles would become my thetas. So I'm going to do 5 in the direction of 0, 0 in the direction of pi over 6, -5 in the direction of pi over 3, 0 in the direction of pi over 2, so on and so on. So I'm going to go ahead and plot these. So 5 in the direction of 0, and then 0 in the direction of pi over 6, which would put me at the pole. And then -5 in the direction of pi over 3, which means I would go towards pi over 3, but then I need to go the other way. So I want to make sure I do the correct line. Yes, okay. Should be down there. And then I need to go back to the pole, and then 5 in the direction of 2 pi over 3, which would be over here. Yep, and then that last point will put us back where we are. So what's going to happen is we're going to start at this point over here. And then I'm going to go towards the pole. Whoops, I cannot draw to save my life. And then passing all the way back around, like this. So then your arrows. So hopefully you remember the order of the segments for the roses we do care about. So this would be 1, 2, 3, 4, 5, and 6. So it's going to be the same idea for the others. I would just recommend you draw or create a table and then do it that way. That's just my advice. I will say the values for where you have 5 petals, those values are going to be kind of gross. I did include this information up here to kind of give you an idea, because we are going to be referencing pi over 12 and pi over 10. So I'll just kind of leave that tidbit of information up there for you. Now with even, so I'm just going to, once again, I'll just do one of these. So I'll do the sine one this time, since we did a cosine one. So whenever the number is even, you're actually going to double that inside number in the argument, and that's going to be the number of petals. So meaning, for 26, because I have 2, we're actually going to have 4 petals. But over here on 27, I have 4, which means we're actually going to have 8 petals. And then on 28, there's 2, which means we're going to have 4 petals. And then on 29, there's a 4 here, which means we're going to have 8 petals. So yeah, let's do 28. So with 28, this tells me I'm going to have a petal length of 8. We're going to be symmetric about the y-axis in some way. And then we're going to be graphing 4 petals is what this tells me. So once again, I'm going to go ahead and do the period value down here. So the period, which is going to be 2 pi divided by my b value, which is 2, which tells me the period is going to be pi. And then for the spacing, I'm going to divide it by 4, which means I'm going to count on my table by pi over 4. So once again, I'm going to make my xy table. So I'm going to count my x values by pi over 4. So 0, pi over 4, 2 pi over 4 would be pi over 2. And then 3 pi over 4, 4 pi over 4 would be pi. And 5 pi over 4, 6 pi over 4 would be 3 pi over 2. Then we're going to have 7 pi over 4 and 2 pi, which will be 8 pi over 4. So when I plug in these values, I'm going to plug them into the original equation. So 8 sine of 2 theta. So I'm going to do 8 sine of 2 times 0. Excuse me, y'all. So we're going to do 8 times sine of 0. Sine of 0 is 0, which means we're going to start at the pole. So now for the next point, so 8 sine of 2 times pi over 4, which is pi over 2. Sine of pi over 2 is going to be 1 times 8, which is going to give me 8. And then we're going to have 8 sine 2 times pi over 2. So that's going to be sine of pi, which is going to be 0. And then 8 sine 2 times 3 pi over 4, which that tells me that's going to be sine of 3 pi over 2, which is going to be a negative 1 times 8, which is negative 8. Then 8 sine 2 times pi, which is going to put me back at 0. Now, I see a pattern happening. So every other value is going to be 0. And then when you do alternate the 8s, they change signs. So what that tells me is this should be an 8, and then we should go back to a 0. And then we're going to go back to an 8, but it's going to change signs, and then go back to 0. So that's kind of the pattern I noticed. So now I'm going to plot these points. So I'm going to go 0 in the direction of 0, 8 in the direction pi over 4, 0 in the direction pi over 2, negative 8 in the direction 3 pi over 4, which actually tells me I'm going to go towards 7 pi over 4 since it's negative, 0 in the direction pi, so on and so on. So I'm going to do 0, comma 0, which is where we start. Then pi over 4, or in the direction of pi over 4, I'm going to go 8, then back to the pole. And then I'm going to go to 8 in the direction of 7 pi over 4. So right now I can see we're doing this pattern. So the right half of the graph. Back to the graph. Then in the direction 5 pi over 4, which means I'm going to go up here. So that tells me, nope, we're going to start at the origin, come back over here, here. I want to make sure I'm going in the right order, y'all. Seven pi over 4. It should be down this way and then up. I believe so. Okay, then that last point over here is going to be going this way. Ooh, Lord, y'all, my brain stopped working. Yeah, that should be my last point. Yeah, sorry, y'all. So I was right. I'm going this way, this way, this way, this way, this way. There we go. So pole, pi over 4, pole, 7 pi over 4, pole, 5 pi over 4, pole, 3 pi over 4, back to the pole. I'm going to redo that. Close enough. So, all right. Hope you had fun. Hopefully you practice some of these. So, making choices. Bye.